Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Afif Syimir and I'm a postgraduate student from University Specialist, and I'm going to presenting about my thesis chapter 1. So this is basically my title, Development and Characterization of Graphene-Based Flexible Sensor on PET Substrate for Cardiac Biomarker Detection. So basically, I divide into the four part, which means first part, development and characterization, which means I will develop and characterize of what I will develop. This is a graphene-based flexible biosensor. I want to make it flexible. So for my thesis, I will make it flexible, which is now we use rigid biosensor on PET substrate. PET as my substrate because PET can be flexible. So I'm using PET for cardiac biomarker detection. Cardiac biomarker detection is kind of biomarker which I will detect in on my cardiac vascular. So which means I will use a cardiac troponin I, which is one of biomarker. Next, this is my research background. My research background at first part, I propose the common biosensor, which is biosensor is used because it can detect real-time monitoring for simplicity, portability, and low manufacturing cost. So for the second, I state if I want to make it I want to make it flexible, I need to make it a device soft, pliable, and with elastic material. So my material is will be graphene, which is nanomaterial. It can be elastic and it can be used for the flexible biosensor. And then this I can state a few example of nanomaterial, which mean gold nanoparticle, silver nanomire, conductive polymer, which is I will fabricate it together with my flexible sensor, which is PET as a substrate. So I will make it conductive polymer, which is conductive and easy to detecting biomarker situation. And last, I state it why I use hybrid ionic composite is it because to allow a sensor to analyze a complex biosensor with the stable electrical performance, which is at last I want to make it electrical performance is very good. Next, this is my references. I use almost a 20 plus something references for my research background. And this is an example. I use a flexible and wearable electrical mechanical sensor for health and safety monitoring by Elsevier. I use this as an example. So I study this using how to use flexible and wearable, an example of flexible and wearable form that other kind of researchers use. And this is a nanostructure wearable. So I study how the nanomaterial and nanostructure it can lead to the very good conductivity and very good resistivity. This is which mean I will detect it very good, and in order to get a very selectivity to the my flexible biosensor. So this is also the example paper I use, flexible medical device for material innovation and data processing. So at last I will process the data to reflect my flexible biosensor detection. And problem statement. So what is problem statement I got is we want to detect cardiac biomarkers such as cardiac troponin I and cardiac troponin T. So I want to make this a low sensitive uh, because the nanomaterial actually graphene is very good in electrical conductivity, chemical tolerability, because I use this. So this research aims to address this challenge by fabricating a graphene-based flexible sensor using gold electrode and PET substrate followed by surface modification and characterization. So I use a gold electrode on PET substrate, which is my flexible things material, which is PET uh, to detect cardiac biomarker. Okay, this is a research gap. Research gap I got from a lot of paper. This is used kind of another that kind of the another flexible sensor, which is we take example first. We detect the research detect heart attack by using screen plate PB working electrode. So it can detect sensitivity cost 0.15 millimolar from ratio detection 1 to 5 millimolar using enzyme. So this is how we detect it. Example, lung cancer use VOC brief to detect it. So this is my research get. I use a lot of a lot of a lot of paper to make a research get this, which mean I use the methods better methods I use to get a very good sensitivity and detection which to detected biomarkers. So this is my objective. My objective to deposit and optimize graphene film on pad. So I use this kind of the graphene which is nanomaterial. I will optimize this on the my pad to detect it, to modify and functionize the graphene surface. This graphene surface, sometimes you can make it as a carbon nanotube or silver nanomaterial. So it depends on the how kind of flexible biosensor you want to make it, and to make it easy to detect the biomarkers. And last, to perform morphological, structural, and electrochemical characterization of the fabricated biosensor and evaluate it. So I will perform the electrical characterization. So by data, I will know and how selective and sensitivity my biosensors. Okay, this is my research code. The experimental study has investigated parameter that affecting info and quality of thin film graphene on pets. Only one cardiac biomarker is used, so I will use cardiac troponin, which is one kind of biomarker is used in my cardiovascular. So there's a lot of biomarkers in our heart. So I will use cardiac troponin. Biomarker concentration and electrical response be measured using EIS. So EIS as a mitral electrochemical impedance spectroscopy, I will use to detect the electrical response. So at last, I want to make it sensor sensitivity, and selectivity be measured. So I want to make it selectivity and sensitivity. So which means I want to detect it as low as I can. The goal, my goal is parameter I want to study from my research gap, which parameter can be used to optimize uniformity graphene thin film on pet set. What the methods I will use from the research gap, and can it is can the from the research gap I can detect as low as I can. So expected outcome, I am successfully to fabricate the flexible graphenes with the kind of nanomaterial with all a lot of nanomaterial to get is the best better. So my second, enhance biomarker selectivity. So I want to enhance the selectivity and sensitivity that as low as I can to detect the biomarkers. And number three, comprehensive characterization the fabricated sensor morphological. So I can detect this through my morphological and sensing instrument also, which mean kind I will detect this by using like example scanning my micro uh, microscope or scanning electron microscope. So detecting the electron transfer and the morphological of learning. Demonstration of effective sensing performance with measurable changes and development a low cost, flexible, and highly sensitive. So I want to make it a low cost, flexible, and highly this is expected outcome that I can meet it to as low as I can and flexible as I can and sensitive as I can. So that's all from the chapter 1. Thank you.